In the last lesson, we talked about creating and graphing equations using standard form. So we can also create and graph equations using the X-intercept. So we call this factored form, and it can look like this, or they can just give you the zeros. So they can give me both my X-intercepts and a point on the graph, and I'm able to turn it into the factored form, and then from there go to standard form and create my graph. So we're going to do this problem like our other problems. I'm going to use example 1 from page 168, and we're going to follow our steps. So example 1 on 168 gives me the 0, so I have my two X-intercepts, which are 2 and -2, and then I know that the graph has the point 0, 3 in it. So my first step is just to identify the information you were given. So we just said that we have our zeros and we have the point. So I'm just going to write that out so I remember. I have the X-intercepts, which are -2, 0, and 2, 0. I also have the point 0, 3, which also happens to be my y-intercept. Because that's a x value of 0. My next step is to plot the zeros, which we also call our roots in our X-intercepts. Remember, they all are the same. And then we have to write them as factors by writing the zeros as expressions set equal to 0. So what I mean by that, so first let's just plot them on our graph because that's easy. I know my X-intercepts are -2 and 2. And then what I mean by expressions set equal to 0 is I know that my X-intercepts are x equals -2 and x equals 2. So what I can do is I can rearrange this equation so that everything is on one side of the equation and it equals 0. So I'm kind of undoing solving an equation. So what I'm going to do is add 2 to both sides because I know that's how this will go away, and I get x plus 2 equals 0. I need to do the same thing for this one, and I get x minus 2 equals 0. So that gives me my two factors. That gives me this portion of the factored form. Now I can find a by plugging into the formula. So in order to do that, so I know my generic formula is f of x equals a x minus, here are the two parentheses, 2 and x plus 2, because I'm using these factors that I found and plugging them in for the factors there. I can't solve for a yet because there are still too many unknowns. But what I can do is use the point 0, 3, the one that I was given, and plug it in to this equation. So I know that 0, 3 is just an x and a y value, or an x and an f of x value in this case. So I'm just going to replace those letters, and I'll use a different color so we can just really see that, with those numbers. So we know our y, or our f of x value, is 3. Then we know we still have our a. X is 0. Minus 2. Close parentheses. 0. Because we're replacing all of our x's with 0 plus 2. And then I can just solve. So I have 3 equals A. I'm going to simplify what's in parentheses, so this just becomes -2, and this just becomes +2. I'm going to do -2 times 2, which is -4. I'm going to divide both sides by -4. And now I have A equals -3/4. Then what I need to do is simplify to standard form. Because right now I have the factored form. So factored form of my equation right now, since I have A, is, didn't quite give myself enough space here, is f of x equals -3/4 x minus 2 x plus 2. So that's the factored form of it, but I can undo this factored form. I can distribute and get this graph in standard form. So what I'm going to do is start with what's in parentheses, and I'm going to do x times x. So let's bring this down here. We have f of x equals -3/4. And then in our parentheses, we've got x squared plus 2x, -2 times x minus 2x minus 4. This 2x minus 2x cancels out, and I have f of x equals -3/4. And then I have x squared minus 4. And then I distribute this -3/4 to both these terms, and I get my final standard form. -3/4 x squared plus 3. So now I've done step number 4. I have it in standard form. Normally I would not squish it all on here. This is for the sake of having it all in one location for your notes. But always give yourself enough space to have your steps written out neatly. Okay, and then we want to finish graphing using the vertex and the axis of symmetry. So I actually, from my standard form, I know my y-intercept. Like I said, we already knew our y-intercept because they gave it to us, but just for the sake of our steps, we're going to plot the y-intercept, which is our c value, which is our constant here at 0, 3. I need to find my axis of symmetry. So what I'm going to do, and we already have our axis of symmetry because you can see it right here. That's symmetric, right? But let's just find it on here. So we're going to finish graphing using the vertex and the axis of symmetry. So x equals -b over 2a. B in this standard form equation is 0 because there is no term with just x. So this becomes -0 over 2 times -3/4. We know that that is just 0, which matches up because we were saying that this is my axis of symmetry. And I can connect my dots and extend the line. If you want more than just 3 points on your graph, you can plug in other x values into your equation to find more points. So I'm going to do that really quickly just so we can see it. So my equation, we got -3/4. I'm going to plug in -3 squared plus 3. I do not want it in that form. I'm going to turn it into a decimal. And so I know that there's another point at -3, -3.75, which means that there is that same point across the axis of symmetry, and I can connect my dots a little bit better now. and draw my parabola.